Good evening, everyone. I am Shamir, and the past 3 years onwards, I have been at the open source DB working as a database engineering. Coming to my day-to-day basis, I am working as a, I am working on the Postgres and coming to my hands-on experience was doing the L1 and L2 from the couple of the customers RN Pro and Estel and Toyota in final services and come like based on the daily basis, like I am scheduling setting up the streaming replications and doing the DCDR drills and DCDR drills and after that parameter tuning and performance to optimizations on the sequels and yeah, that's it. Coming to my foundations was mostly on Postgres and like uh, I under Python and some of the basics of Linux and HTML and CSS. Yeah, let's go to the agenda. Introduction about the explain plan and why we need to use the explain analyze and how in Postgres execute the query using the planner and executors and understanding the scan types in Postgres, understanding the buffers options and using with explain analyze and adding to some more information on that web browse output explain. Some of the practical tips based on my experience I have added on that. Like seeing the daily basis like from the last few months onwards like some of the queries was executing more taking to time much time previously it was taking like less times in the seconds only, but coming to for the last 3 months like most of the queries was executing on much time 3 to 10 minutes. Based on those things, like I thought I can tune the optimize the queries and all like using the couple of the explain plan. It was showcasing the query was only estimation perspective data it was showcasing, but coming to the explain analyze when out we are using, it was showing the real-time basis statistics of the information and all. Like using some of the examples I have taken here, like explain plan, like select to start from table. It was trying to scanning the overall the table. Here was the cost equals to it was whenever the first row was trying to accessing retrieving the data from first row, it was starting from 0.0 milliseconds to complete the overall the retrieving the table. It was taking almost was 94,000 200 milliseconds. Yeah, but the overall the estimation rows was it was almost was 5,000 million rows were there in the table, and width of the bytes was 40. Coming to explain and analyze, here we can see the same of the cost perspective, estimation cost and actual when the time when the query was executed on the real time basis on the server, coming to the first row like actual time, it was starting the first row almost was 4 milliseconds and 800, and its completing was almost was 21,000 like 21 lakhs of 38,000. It was taking time to complete the overall the execution of table. Here we can see to retrieve the data, it was too much of time to complete the table it's taking, based on, but still I did not create any indexes on this table just before creating an index this example. Yeah. Using why we use explain analyze, it's helpful to understand where exactly the query was taking much time. Then we can optimize the query different, and we can find out the difference between the estimation plan and actual plan, how much for the real time statistics, like we can see here. And coming to essentially, like to add on top on that, like we can add here some of the indexes, or rewrite the joins, or like we can rewrite the some of the change the query structure plan and all, based on the, like here I have taken some of the columns with where employee ID equals to 1,500 rows. It was trying to gathering what is in the gathering node. It's gather means like it will use the same, like work mems processor worker process in multiple times, and it will gather the information. And like coming to the parallel sequence on the t on the table, like it was showcasing the estimation perspective and actual time, how much of time it was taking. Like actual time was it was showing that like almost was like 1600 milliseconds. Coming to retrieve overall the table, it was showcasing us 2000 second almost, but the rows was it was showing 0.3. For the loops, how many types it was executing on the thing, 3 types. Like to trying to accessing the data, this much of data, it was taking much time. Like this was using some joins. I have added some of the join functions on the query. Like in the joins, like I have added one more table, and it was I have given the some condition using customer ID and a team table equals template temp ID and customer ID. Like it was trying to retrieving the data, almost taking time was like 45 lakhs, and to start the actual process, and to complete the actual process, it was taking much, almost was 1 lakh 5,400 500 5,000 seconds it was taking. But trying to retrieving the data, it's almost gathering was 5 millions of records it's gathering. Like like accessing the specific condition on that. After creating an index on those tables, like index was here we can see the indexes on the table. Like after creating the indexes, we got the lot of the performance was improved on, like to retrieving the data on the employee ID. It was like completing in the 2 seconds only. But the overall the time it was lot differences between the estimation perspective and the actual time it was seeing. But coming into the after in the same after joins, like we can see the actual time was it was taking like 18 lakhs, and when the actual start was trying to accessing the data, but it's fine to retrieving data, and once it's checking the row by row, after that to complete the table, like overall accessing the table, it was 45 lakhs. It was taking much time. Total rows it was gathering 5 million rows records it was gathering, and just and like Postgres, how Postgres in the query will execute. Coming to the um, like query first, it once when we return the query, it will come such the take the two methods of there are two methods. One was the planner and second one was the executor. First, it will go to the such which exactly the which table it is, and after that it will scan is there a table indexes or not on the table, and later it will show such that from the is there this table are present in the disk or like it's present in the shared buffers. It will search on that come based on the, after execution. Coming to the execution plan executor, it will show it's colors the query from on the specific table, and it will execute the query, and it will pop up the information from the disk or from memory buffers. Types of scans in Postgres, coming to sequential scan. Sequential scan is nothing much. It will whenever the actual start when we writing the query, it will enter the first to the table, and it will try to access the first row, and it collects the to retrieve the data first row, and it will pass the condition. Until it will pass the condition, it will check the row by row and to complete the query, and it will show the information to us. But coming to the index scan, index scan will be using B-tree indexes or other indexes to fetch the information on using the specific call specific rows on the table, it will shows the information. Coming to the bitmap indexes scan, bitmap index scan, using the bitmap is the tab. Whenever we in the query, we have the multiple indexes on the query, using those indexes, it will showcase the it will take the planner as a two parts, and it will color the information, and it will shows the it showcase the information to us. And coming to the parallel sequential scan, was whenever we have the larger tables. In the larger tables, it colors the information on you with using the multiple codes or workers. You taking the use of workers, it will run the at the same time. It will split the operations multiple small chunks, and it will gather the information on the same time. But coming to the parallel index is similar to the parallel sequential scan, but here it was using the indexes to gather the data from the fast way. And index only scan was in the table. Whenever we have the rows on the different indexes on the table, it will use the indexes based, it will did not use the table. It only use the indexes, and it will shows the information to us. When we use the sequential scan and indexes scan, indexes scan, sequential scan was whenever we have the small tables, and it was trying to retrieving the data from which are there, all the matching in the same query. We can take that sequences scan. And coming to the indexes, we are on the specific, we are choosing the data only specific rows or specific multiple rows, like we can use the indexes. But coming to the indexes and sequential scan was whenever we have the larger tables, it's helpful to have the index scan on the tables. Coming to bitmap index scan and parallel sequential and index scan. Bitmap scan was used like whenever you have the query, in the query, like there are multiple filter conditions like where and operations using like multiple filter conditions was there. At that point of time, we can use the bitmap scan. It's helpful to retrieve the data in the fast way. But coming to parallel sequential scan, like when the parallel sequential scan, whenever we have the larger tables, it's split using to start the process from taking the two cores, and it split the table into multiple small chunks, and it will take the showcase the data, and it will useful when we have the large tables. We can use the parallel sequential scan. Coming to the index only, like when we have on the some tables, on the table like a column ID and name, and in the column last name, like we can take the based on that columns, we can use the index on that columns, and it will gather the information as fast, and it will showcase. This index only scan will be useful whenever in the query we have a table, all the indexes was there, based on we can choose the index scan on. Understanding buffers in Postgres, like buffers are nothing much whenever we are accessing the data or trying to modifying the data, when you are doing the when you are trying to modifying the like retrieving the data, first it will goes from the disk, and it will gather the information. It's take much time, but coming to like it was using the same query in the multiple times, but the data will be stored in the buffers, and it will showcase the fast. And coming to the track I want. Using the analyze with the buffers, it will showcase the more information, like where exactly this query taking much time, and this information collecting from the buffers, or from the disk, it will showcase to us. Coming in the explain is with buffers, here we can see the index scan on the team table, it was actual condition was equals to 1,500,000 records, but below we are able to see here buffer shares is nothing much. The data was trying to gathering from the buffers, whenever here you can see one more thing, in the reads was whenever you is there a read here, reads was missing there, I think. Yeah, here we can see buffer share hits was it was trying to gathering from the shared buffers from the information, and it was showing as a fast. And coming to the reads, it was gathering the data from the disk, and it's taking much time. At that point of time, we can try to optimize the query and all. like coming to verbose, like verbose will give them more information on the comparing to the buffers, it will add some uh, where exactly what is the part we are trying to retrieving the data, and which are the column specific columns we are taking the information, and all it will showcase to us. uh, Here we can see after we are given the web browser, it was trying to showcasing the output of the employee ID and employee status here. The condition was team ID equals 1000. Like these are the two columns. It's trying to accessing the data. Based on my experience, I have suggesting use the explain plan, and with analyzing buffers, it will helpful lot to optimize the query and all, where exactly the query was taking much time, and where exactly the buff it was taken from the disk or buffers, we can able to see, and we can optimize the query, or rewriting the indexes, or we can add the joins, or like we will change. Here are some of the references I have learned from the if you want, please go through. Thank you. Let's. If you have questions,